Now we can see the synchronous impedance model or EMF model. It is one of the main model to find out the regulation of the alternator. In order to use this method, we need the following data. First one is the armature resistance per phase, which we can found out by the voltmeter ammeter method as we have already discussed. And the second one is the open circuit characteristics, which is a graph between the field current and voltage, open circuit voltage, V phase. The third one is the short circuit characteristics, which is a graph between field current and the short circuit current. The circuit arrangement for conducting the synchronous impedance model is like this. We have the field winding of the alternator, and the armature winding is a three-phase winding. Since we need open circuit and short circuit characteristics, we need a TPST triple pole single throw switch. Here one ammeter is connected across the line. Voltmeter is also connected, which is connected like this. TPST switch, and the field is provided with the rheostat and an ammeter to measure the field current, and field is excited with the DC supply. In order to obtain the open circuit characteristics, first using the prime mover, adjust the speed of the field of the alternator into synchronous speed. Then keeping the rheostat of the field circuit into maximum position, switch on this DC supply. And since it is open circuit characteristics, the TPST switch should be in open position. And with the help of this field rheostat, the field current is increased. Due to this, flux increases and the EMF induced across the terminals also increases. And we should change the rheostat up to the 125% of the rated voltage of the alternator in order to get the open circuit characteristics. Here, the open circuit characteristics is the graph between V phase and IA, sorry, V phase and IF. This voltage rates, this voltmeter rates the line voltage. We should convert that into phase voltage, and we should draw this. This is the open circuit characteristics. Next is the short circuit characteristics. Short cir- for short circuit characteristics, we need to adjust the speed of the prime mover to the rated speed. That is, the field should rotate at the synchronous speed, and the TPST switch should be closed to position. Since it is short circuit characteristics, TPST switch should be in closed position. So this voltmeter reads 0, and by adjusting this rheostat, field rheostat, we should circulate rated short circuit current of the armature, and we should note the field current corresponding to that rated short circuit current. Using that, we can draw the short circuit characteristics IF versus ISE. This straight line. This is the short circuit characteristics. Then, in order to find the synchronous impedance ZS, which is the which is E1 divided by ISC. ISC rated short circuit current. We know the rated short circuit current, that is the rated value of the alternator, current of the alternator, and we should find out the E1 corresponding to the rated current. For that, what we are doing is we can draw the SCC in the same graph. You see here, this is short circuit current. This is the open circuit current. So what we are doing is we need to find the voltage, need to circulate the rated current. So this is, since assume this is the rated current, rated short circuit current. We need to find the field current required to circulate that rated current. Then the voltage corresponding to the rated current should be received. So this is the event. The same field current is required to circulate the rated short circuit current. That is the open circuit voltage E1. So that's equal to E1 divided by ISC rated. Using this ZS, we can find out XS, synchronous reactance XS is equal to root of ZS square minus RS square. And we know the equation of the loaded alternator, that is E phase equal to root of V phase cos phi plus IARI the whole square plus V phase sin phi plus or minus IAXS the whole square. From this equation, V phase is the rated voltage, cos phi is the power factor of the load, IA is the rated armature current, RA is the resistance of the armature, and XS is the synchronous synchronous reactance which we have obtained from this ZS square minus RI square from the EMF. From this we can find out E phase. Here positive sign, in this equation positive sign for lagging power factor load and negative sign for leading power factor load. And we can find out voltage regulation like V phase equal to E phase minus V phase by V phase into 100. This is about the synchronous impedance method or EMF method. Thank you.